Good afternoon, everyone, and welcome to the latest session of the second annual CUTRIC ZEB conference. My name is Karen Cameron. I'm the CEO of the Ontario Public Transit Association, and it's my absolute honor to be moderating this session this afternoon, The Promise and Realities of ZEB Solutions. I'm pleased to have on the panel today Parvathy Pillai of CUTRIC, Bem Case with the TTC, and Kyle Catney of YRT, all three of whom are very good friends of Opta and all the work that we've been doing together. So with that, I'd like to first bring on Parvathy for our first presentation.
Thank you so much, Karen. Thank you for the opportunity to present CUTRIC sub-consulting services studies that are relating to the battery electric bus performance here. So as you know, we launched our third generation of the tool set yesterday with respect to RUDI as well as Cloud Transit. And here we are going to be talking about the performance of battery electric buses in the predictive sense. In terms of the RUDI tool, the tool has a lot of functionalities and some of which are listed here, but fundamentally, this is a tool that is capable of predictively assessing the performance of zero emission solutions before they are deployed. So we are going to see what some of the predictive performance outcomes emanating from a study that we undertook in Ontario are looking like. So I have chosen a sample of 3 transit agencies in Ontario for this particular exercise. And what we have in this particular slide is the anonymized results from those 3 agencies. These agencies are in Ontario, but they have different fleet sizes. So agency number 1 is having a fleet size of around 500 buses. Agency number 2 is having a fleet size of around 200 buses. Agency number 3 is having a fleet size of under 100 buses. So this particular transit agencies are having an average fuel efficiency as noted in the table on the left hand side there. We are measuring the average fuel efficiency or fuel economy, if you wish to call it, as kilowatt hour per kilometer, considering the amount of energy that the average bus would take at this particular transit agency, given their topographical conditions, given their ridership constraints or opportunities to cover 1 kilometer of their fleet. So for transit agency number 1, they would be expecting to expend around 1.65 kilowatt hour per kilometer. In the case of the second transit agency, they should be expecting around 1.27 kilowatt hour per kilometer. And for transit agency number 3, it would be 1.45 kilowatt hour per kilometer. So this is the range of fuel economies for these 3 transit agencies. On the right-hand side, what you're seeing is the depot-only charging success rate. So when we do this predictive performance modeling analysis for our transit agency colleagues, they would like to see what is the art of the possible with respect to the depot charging alone and the complementarity introduced by having depot plus opportunity charging. So in this particular case, we are looking at the depot-only charging success rates in percentage noted on the y-axis, and on the x-axis, these 3 transit agencies are listed with the relevant color codes. So what is success? How is success rate measured? So we are looking to see if a bus that is exiting out of the garage at the start of the service day with 100% state of charge in their batteries are coming back to the garage with at least 20% state of charge remaining in their batteries. If the buses are coming back with 20% state of charge or more, they are deemed successful because they were able to successfully complete the service requirements that the transit agency has. If for any reason the bus is having a state of charge of less than 20%, they would be deemed as a failure. The reason is the 20% cutoff is an industry best practice standard to ensure the battery longevity and health of the batteries, to avoid the transit agency spending money unnecessarily to replace batteries sooner than needed. So that 20% cutoff is key for us to evaluate the performance of these assets. And here we can see that in the case of agency number 1, that was expending 1.65 kilowatt hour per kilometer, their success rate with depot only charge charging is just under 60%, which means that more than 40% of this transit agency's fleet would run out of power somewhere during the service day if they are reliant exclusively on depot-only charging. For agency number 2, which is having a fuel efficiency of 1.27 kilowatt hour per kilometer, the success rate is crossing the 70% mark with depot-only charging alone, which means that this agency would have a higher rate of success with respect to depot-only charging, with 30% or less of their fleet only running out of power midway. For agency number 3, this is an agency wherein there is no way they can fully electrify their fleet utilizing depot-only charging unless they chop their blocks, because with a fuel efficiency of 1.45 kilowatt hour per kilometer, the depot-only charging success rate is close to 15%, which is telling us that more than 85% of their fleet would be running out of power somewhere during the service day. This is a golden piece of information for the agencies to consider when they are evaluating what is the art of the possible with respect to battery, electric powertrain, and electrification using depot only versus depot and opportunity charging. Here, we are going to be looking at the depot plus opportunity charging success rate. So as I previously articulated, it is never depot charging or opportunity charging. It is depot charging or depot and opportunity charging. So in this particular case, the expectation is that the transit agency would be having like a 100% state of charge, leaving the garage at the start of the service day and getting back to the garage with the 20% or more. But the expectation is that these agencies buses would be having an opportunity to charge, to top up at an opportunity charger during the service day, more or less once every round trip. So the energy efficiencies are the same because the configurations of the buses that are capable of absorbing power at an opportunity charges versus the depot charger are the same. So in this particular case, if we focus on the charging success rates alone, you would notice for agency number 1, the success rate increased from where it was to more than 85%, so crossing the 88% mark. For agency number 2, they are at the 100% mark. For agency number 3 as well, they are more or less at the 100% mark. So opportunity charging is what was required for agency number 2 and 3 to fully electrify their fleet in terms of acquiring the necessary charging required without adjusting their blocks. In the case of agency number 1, to account for the remaining 12% that is lacking charge during the service day, that is where the schedule adjustment may come in play along with some block readjustment. So in terms of the depot only charging versus depot and opportunity charging challenges and advantages, and through this ZEP conference, I know we have heard colleagues from all over the country talk about like the challenges, opportunities, and the real life experiences of battery, electric, hydrogen, RNG, etc. This is a nutshell comparison between the two opportunity depot and opportunity charging versus depot only charging considerations. In terms of the challenges and advantages, there are more challenges and advantages, but these are what we can focus on for now. In terms of the challenges, if you are focusing only on depot only charging, there is larger replacement ratios because you might end up having to procure more buses to cover your service requirements and larger power demand charges, because if you are plugging in to the depot at the end of the service day altogether, then your demand charge can hike up. In terms of like the advantages for depot only charging, of course, lower capital costs. The opportunity charges are much expensive than the depot versions, and the lower number of equipment to maintain because you wouldn't need to worry about the on-route deployment of this. In terms of the depot and opportunity charging, the challenges involve the high real estate costs. CUTRIC is a leader in this space wherein we do not just feasibility modeling and predictive analysis, we do like facility assessments and considerations for retrofits and mechanical, architectural, civil engineering considerations, etc. And when you actually go into a site and assess its suitability for installing an opportunity charger, there are a lot of real estate constraints and architectural constraints along with electricals that come associated with it. So the high real estate cost in a nutshell can be a way to encapsulate it all. installed. The schedule adjustments come necessary because you need to not only install these opportunity charges, which are high capitally intensive to begin with, but you also would need to look at your schedule to see if you can tweak it and make an optimal schedule possible to create like a room for charging, because it has to have like the docking time for the bus to connect with the charger. It has to have time for the charging to complete and then undock and then leave the charging station. And in doing so, you would have to manage passengers as well in terms of onboarding and disembarking as well. In terms of the advantages, depot and opportunity charges charging scenario presents that you do not need to have as much charging times at depot, because most of the time depot has low power charging, which means that it might take longer. In the case of like empowering the buses to have the opportunity to charge on route would mean that you do not need to have a longer charging time at the depot, and lower battery capacities are also required, because when you have a higher battery pack on the bus, you are carrying more weight and then reducing the number of passengers that you can carry on your buses. If you have like opportunity charging, then you can still work with a lower battery capacity, still have the room to carry more passengers as well. So the lower battery capacity can translate to lower capital cost as well in terms of bus purchases. So these are the key comparisons between the challenges and advantages for the depot only versus depot and opportunity charging. So in terms of facility considerations, I already talked about it a little bit in the previous slide. At CUTRIC, we do this as a part of our ZEB implementation planning. So for a transit agency that is coming to CUTRIC to do predictive performance modeling, once they have the results, then they would be considering, okay, what to do next. The next step is actually plan for an implementation, wherein you need to consider all the different elements from the economic lens, from the social lens, from the scientific, the technical side of things, and from the environmental phase, as I said, to create like that solid business case that empowers them to have an implementation plan vision that steers the ship forward. So in terms of the facility considerations, most of our transit agency colleagues would want to retrofit their facility. Some would want to consider a greenfield assessment, but most of them would like to see if they can utilize their existing facility and retrofit it to make room for the energy transition. And in that particular case, we would look at the size of the electrical service, the transformers, the ability of the utility to provide power. And this is a key consideration. We always ensure our utility partners are at the table from day one. Even if you are doing just a feasibility study, we would always engage the utility, because they are the ones who would be providing power to the transit agency who is planning the energy transition, and they need to be clear on what the demands that it would be placed on them down the road. So we engage the utility from day one, and the size of the transformer, the ability of the utility to provide the power for which they may need to do like adjustments on their end most of the time are critical. The mechanical, civil, and architectural considerations, the weight of the charging equipment, the ventilation, cooling of the charger room, the required physical space, the charging cabinets, all of these things are key considerations for a transit agency as well. And we do like site assessments to ensure like we consider all the current assets available to optimize and maximize the utilization, to ensure the capital expenditure from the side of the facility modification is reduced, but it is still something that the agency would need to consider. Other considerations include tools, spare parts, cranes for lifting battery packs, scaffolds, staff training, PPE. All of those are also part of this, because you are having your staff work with these high voltage systems, and there are a lot of training requirements, PPE requirements, and additional investments in that regard as well. And more importantly, like this is change management at the core of it all. So you got to have like that dedicated project team, data scientists and engineers and mechanics and electricians working as a team to make sure energy transition is as seamless. And I'm happy to say that CUTRIC has supported many transit agencies. We are happy to continue supporting multiple in our new with our new improved tools as well. So thank you very much. Back to you, Karen.
Thank you, Parvathy. As I'm listening to your presentation, I think back to 7 years ago when I joined and when CUTRIC was getting going and we were first doing the Pan Ontario electric bus demonstration, how exciting it is to now have this kind of expertise and and the immediacy of information that we didn't have then. So thank you again. I'd like to call on Bem Case, a new position as Executive Director of Sustainability for the TTC and also the Chair of the Opta Zero Emission Bus Committee. It's been my pleasure to work with Bem on that over the past year. So over to you, Bem.
Hi, Karen. Thank you. So I'm going to go through our emission targets, an update on our green bus procurement, the infrastructure program, the latest results of our eBus head-to-head evaluation, lessons learned from that exercise, and what's next for TTC. So many of you will know that the City of Toronto had an already ambitious target to achieve an 80% reduction of greenhouse gas emissions over 1990 levels by 2050. That's been updated recently in December by City Council, approving an even more ambitious target of achieving net zero by 2040. The TTC back in 2017 set a target for a procurement of only zero emissions buses starting in 2025 and all zero emissions fleet by 2040. So we're aligned with that, of course. The Green Bus Program update. So we have currently 255 of the latest generation hybrid electric buses, propulsion by BAE. Allows us to do geofencing of EV mode in garages and at stations to prevent emissions in those areas where people are most exposed to diesel emissions. So a significant benefit. These over 300 buses that we're now seeing coming into 2023 will bring that fleet up to close to 600 buses in all. Then we're planning to issue a RFP for the next eBus procurement in the coming days, and that will be for approximately 300 buses with the potential to extend that procurement quantity further as we seek funding before contract award. Targets. So I mentioned that we have a target of procuring only zero emissions buses starting in 2025. As you can see from the procurement plan there, that actually would be advanced by 2 years. So we're looking to start procurement of only zero emissions buses starting in 2023. This also accelerates the adoption of zero emissions across the fleet. And with the procurement frequency you see there, which are largely the state of good repair, end of life replacement of the diesel fleet, and then eventually of the hybrid fleet, we would have a zero emissions fleet by 2037, a few years ahead of the 2040 target. Major interdependency, of course, to allow us to do this is to install electrification infrastructure for these buses ahead of their delivery. This is very difficult, if not impossible, to make out, but I'll just describe what it is, the message I'm trying to get through this. The bottom line has the same procurement numbers that you saw on the previous slide for e-buses, so 100 buses in 2023, 133, 167, 170, and so on. And the colored boxes show the quantity of buses from that annual procurement that's going to go into the 8 garages that TTC has. And you can see what we're looking to do is to phase in the e-bus fleet at each garage to allow that garage to become familiar with e-bus operations before it's fully dependent on e-buses to make its daily service. And so through that phasing of work over the next number of years, we get to 100% electrification. This is assuming at the moment that's in depot charge buses. That brings us right through to 100% electrification. It may not be the case that the last maybe 20% of our fleet is electrified through depot charging. It may be that we need to go en route or for en route for opportunity charge buses, or otherwise a hydrogen fuel cell. So that's a question mark. But this is a plan nonetheless to get us to full electrification with depot charge buses. And to ensure that we meet this ambitious plan, we've partnered with both OPG and Toronto Hydro, where Toronto Hydro would increase the feeders to our facilities and ensure reliable supply of electricity to each of our sites. Power On, which is a subsidiary of OPG, Ontario Power Generation, would co-invest in, own, operate, and maintain, design, build, I should say, to begin with, all of the electrification infrastructure required on our sites to charge our buses. We would then, of course, charge our buses and deliver service. The eBus head-to-head evaluation. So when we procured the 60 buses we have today, and that makes up the largest fleet in North America to date, we procured from the only three, what was then the only three manufacturer of long-range electric buses, BYD, New Flyer, and Proterra. We had just procured hybrid electric buses from Nova Bus, and it had been performing so well that we decided to use that as the standard against which we would evaluate the performance of the electric fleet. We used 9 evaluation domains that you can see here, and so we looked at system compatibility and interoperability. We looked at accessibility, of course. We looked at the customer experience. We evaluated that ourselves. Of course, we also surveyed our customers. We've been evaluating ourselves again, the experience through operations trials and maintainability routes, maintainability demonstrations, sorry. And we've also surveyed our operators and maintainers. We continue to do that. We continue to, of course, track costs and improve our lifecycle costing model as time goes by. We've been evaluating vendor performance through a number of different metrics, and you'll see some of those here. Of course, vehicle performance and charging system performance. So last year, this time, in April of 2021, we reported to our board the first set of results for our head-to-head evaluation. This is what you're seeing that we had presented back then. And you can see that that with Nova Bus, their hybrid electric bus met all these requirements. It's a hybrid bus, of course, so it's not, the charging interoperability is not applicable, but we know now, of course, that they're producing and are offering to the market a long-range electric bus that is SAE compatible, so their future long-range bus will be compatible. And you can see at that time that the New Flyer bus in particular was performing very well. And I direct you to our public board report of April of last year for details on the kind of the metrics behind how we came to these conclusions. Looking at the key metrics of vehicle performance specifically, and again, there's a whole suite of domains and different metrics that were used to evaluate the performance and to inform us whether the electric bus technology was ready for full-scale adoption. But the key metrics of vehicle reliability and fleet reliability, because our operations, despite what we might want to do, all those benefits, and I mentioned in a previous session, brought a very wide set of potential benefits with electrification. But at the end of the day, we as a transit operator, we have to deliver service every day. Pre-pandemic, it was 1,700 buses peak service to be delivered each day, and with a fleet of just under 2,000 buses at that time. And so we can't make decisions today that will adversely impact our ability to deliver reliable service. Because in fact, the largest thing that people can do to reduce the impact of climate change is to take public transit. So public transit needs to be, well, active transportation, public transit, it needs to be reliable. So the dots here that you're seeing on the screen is the status of the how each manufacturer was doing in terms of reliability back in 2021. So you can see here that the purple dot BYD was just below the target, the reliability. You look at New Flyer, which was above the target, Proterra, which was also just below the target, and of course the hybrid bus from Nova, as I mentioned, is the kind of standard mark, and you can see that it's performing very high, right? Very well. So the lines, though, the trend lines now show the trend line from the point of entry of service to roughly today, where the line ends. And you can see that if I start with the baseline, Nova is still performing very, very well. You know, 2 times, what's that? 3 times, 2.5 times the target. We see New Flyer continues to perform well. You see that their trend line, you know, from the point where they were last year, they've you know, they're on trend to in fact exceed the performance of the hybrid bus. So it's performing very well. Both BYD and Proterra are trending in the wrong direction, unfortunately, but we continue to work with them, obviously, to improve that performance. Fleet availability, you can see a very regular, and this is what you need to see in the red line at the top with Nova Hybrid, a very regular performance of fleet availability, very dependable vehicle. So it's not just high performance, but it's also dependable. So you can see that its performance was quite high in the 95 plus range percent availability for service each day. And this is roughly where they're at today, and they continue to have seen, you see that line there, again, a very steady performance. When we look at Proterra, New Flyer, BYD, again, in this case, New Flyer has continued to perform above the target. You see that there was a trend line largely impacted by modifications done to the vehicle to improve its reliability that showed an initial reduction in availability. There was a kind of doubling down of efforts by New Flyer that has seen an upward increase of availability. So now, again, we're in the 95% range. What needs to be proven here is that consistency. So now that availability has gone up to where it needs to be proven consistent. Proterra as well, as a result of real concerted effort by the Proterra team and my own team, of course, as well, led by Mike Makis and the team of engineering technologists that sit with each and own these fleets. You can see their availability is near 100% now. So very promising. Again, we need to see consistency there. I've only got 2 minutes left, so I'm going to have to go through the rest very quickly. The main thing here on this slide is to show that, you know, of all the different failures, this is showing that the percentage of failures across different systems within the bus. Again, as we had experienced up to the last year this time, the vast majority of failures are not propulsion related. Less than 5% are propulsion related. Lessons learned, body structure. We ourselves, you know, the composite body, we're learning from that. We like the fact that we have that in our fleet. It offers a lot of potential benefits, but we need to see how it performs over the long term. For ourselves, carbon steel frames require annual rust proofing, otherwise they won't stand up to corrosion. And the rust proofing systems right now create some hazards, so that's a concern for us for large scale adoption. For our next large scale procurement, we need to be taking a more conservative approach on the bus platform. As I mentioned, it's a bus platform that's driving reliability and availability of the fleet, not so much the bus propulsion system. So we will be specifying a stainless steel frame with proven in-service experience. And bus dimensions, so we again have to ensure that our bus storage is maintained. We can't take a bus on that's larger than our existing bus design requirements, and thereby reduce the storage capacity. So we're going to introduce a maximum bus length of 40 feet. The bus dimensions, I mentioned that already. The batteries, we're learning that it's not a reliable metric to look at what the OEMs advertise as the size of their battery to determine how far it's going to go. It's not necessarily equate to one another. And so we are going to be specifying a usable battery capacity and maximum performance degradation over time. Lessons learned. So I basically mentioned all of this already. So we need stainless steel structure. We need to have its reliability and resiliency proven through alternative testing and shaker table testing. We need to specify the minimum battery capacity, specify the size of the bus, make sure that we've got roof-mounted pantographs for in-depot and en-route charging in case we need it, and charge ports on either side for plug-in as well. The next step for us, large-scale procurement, as I mentioned, in April, next few days, in fact, we'll be issuing, several days, I should say, we'll be issuing an RFP for 240 or thereabouts 40-foot buses. And we're going to be using the lessons learned as I just described. Emerging technologies, we're not closing ourselves to emerging technologies, however. So this large-scale procurement to stay on the path towards zero emissions is what we're engaging in the next several days. We are going to reserve some of the funding we have available for emerging technologies. So this could be 60-footers. We call it emerging because we just don't have it in our fleet. So 60-foot electric, battery electric, long range, or opportunity charge, hydrogen fuel cell. We're going to just boil down our requirements to a minimum must-have list, and we're looking at maybe a procurement of 25 buses for that. And that's it. Thank you very much.
Thank you, Ben. Lots of information shared there. The TTC has been very open over the last year or so with their experience and their information, as have Brampton Transit and York Region Transit. In Ontario, there are over 40 transit systems that are looking at electrification and sharing information, and this kind of information has been invaluable to speed up the timeline for everyone and simplify the whole process. And with that, I'd like to introduce Kyle Catney of York Region Transit to speak about their experience with the Pan-Canadian demonstration. Kyle?
Great, thanks very much, Karen. Nice to be able to speak to everybody and give you a quick brief overview of the YRT electric bus program. So we will touch on some of our timelines and kind of what we've been doing to get us to the point that we're at today. We'll go through some of our experiences to date, a service summary of what's been happening in the field so far. We'll touch a little bit on reliability as well, operating costs, emission reductions, and some of our next steps. There we go. Okay, so this is a summary of kind of everything that we've been doing over the last 5 or 6 years, I guess. So as you can see from the table here, 2016 and 2017, we really started to dip our toe into what we wanted to do when it came to emission reductions. Very similar to what Ben had noted with the City of Toronto and TTC. York Region has an overarching emission reduction target of being GHG free by 2051. And like most of you are aware, transit fleets are a significant opportunity to meet those goals and reduce emissions. So we recognized our role to play in that process and started completing some alternative fuel studies to really evaluate what would be the best system or bus type to get us to where we needed to be. We also joined CUTRIC and started participating in the Pan-Canadian electric bus trial. The initial focus of that trial was electrification, interoperability, and en route charging. And that's resulted with the initial 6 buses that we had put in service. In 2018 and 2019, we kind of pushed pretty hard for funding to support our programs and had various levels of success, I guess you could say. Ultimately, in 2019, Council authorized the purchase of our first 6 electric buses. That got us well on our way to getting them on the road. In 2020, the first 6 buses went into service. I will flag that, that was also the year that a pandemic kicked off, and it was really an interesting time to start a new trial for, a technology that we really wanted to put through its paces. Obviously, travel patterns and ridership and traffic were all significantly impacted by the pandemic. And really the first year of our trial and a good chunk of the second year anyways, weren't in the same environment that we had previously anticipated and modeled through our planning processes. So that's something that I'll come back to a couple of times through this presentation, but wanted to flag that for everyone. So once we had the first 6 buses on the road and we were able to really start to understand the technology and further build out, our operating profile and costs associated with the electric buses and impacts to service, we were able to then translate it through to a comprehensive feasibility study and implementation plan. And in December of 2021, we presented that to our council and got approval to move forward with it. So at a very high level, what that means for us is between 2022 and 2030, we'll be continuing to purchase incremental quantities of electric buses. And then from 2030 onward, the region would be purchasing nothing but emission-free buses. So that's a good target for us to work towards. And really, it is a phased approach that balances technology adoption with service reliability. And that was key for us. So in 2021, the tail end of 2021, we were actually able to get another 6 electric buses in revenue service. So currently we have 12. And in 2022, we will be adding an additional 2 electric buses to our fleet in the fall. We've also been successful working with the Zero Emission Transit Fund to start to look for opportunities to ultimately support the cost associated with implementing this program. And we're working through right now an application with the ZETF fund. So a lot of good opportunities there to support our program and move the needle on converting our fleet. So a quick summary of some of our experiences to date. What we have found and was kind of expected was the impact of temperature on range. We have been seeing a 25 to 30% reduction in range in kind of either extreme of temperature, whether it's cold or warm. And obviously in those instances, for our original 6 buses, that has resulted with more frequent charging demand on some of our routes that are reliant on en route charging. Overall, customer experience-wise, it's been very positive. A lot of excitement from our customers and interest in the initiative, so that's been really positive to see. We've recently been expanding the electric buses onto different routes and really getting them out there for the public to see and experience. So that feedback's really started to increase quite a bit. On the driver's side of things, obviously additional driver training and support was a big piece of implementing this, especially for the en route charging and ensuring that they understand, how the bus communicates with the chargers, and we can facilitate the successful charge cycles in the field. We did receive a lot of positive feedback as well, just overall on the implementation and the day-to-day operation of these buses. We did initially see a little bit of range anxiety, but I think that was kind of expected as well. And as not only our confidence in the technology builds, so is it for the drivers. They understand now, the work that went into modeling routes and validating that the technology can perform the way that we need it to. And largely that range anxiety has gone away and not something that we're really dealing with anymore. Overall operational impact. So one quick point here, and we'll get into a little bit more detail. We have been tracking maintenance costs associated with electric buses when compared specifically to diesel buses of a similar age. And we are seeing a reduction of about 30% in maintenance costs, which is positive, and one of the key components to making business cases for these types of programs more appealing. En route charging is required to maintain some of our services. That is partly due to the battery pack size of some of the fleet that we have. The new 6 buses that we have in service have a much larger, longer range battery pack, and they aren't reliant on the en route charging for the routes that they're servicing. However, some of the initial 6 definitely are, and that's really allowed us to put that en route charging technology through the paces over the last year and a half. Another big piece of the puzzle as well is ultimately schedule adjustments required to accommodate en route charging. So if you do need en route charging to support electrification of some of your routes, ultimately you need to ensure your schedules can accommodate that to ensure service reliability and not experiencing delays in the field. When it comes to charger usage, driver and mechanic training continue to be a big area of focus. Like I mentioned previously, these are new systems altogether for them, and we've had to implement a number of additional processes and procedures to manage the in-depot charging of our electric buses. We definitely needed a lot of additional post-delivery support, both on our staff and OEM side of things, especially within the first year of the trial. Year 2, things have largely stabilized and are performing where we would expect them to, but the first year there was a lot of bugs to work out, like you would expect with implementing a new technology. And obviously charger reliability impacts bus availability, and that goes for in depot and en route. And if you can't charge a bus, you can't get it in service, obviously. So there's a lot of performance specifications that we're working on to manage that risk of charging our fleet. When it comes to environmental impacts, overall, our electric buses have traveled almost 200,000 kilometers, resulting with a reduction of approximately 170 tons of greenhouse gas emissions. So that's something that we continue to track regularly and is one of our key metrics for moving our program forward. So this is just a bit of a service summary to give you an indication of how things have been going over the 2 years. So we started about mid-2020 with the first 6 electric buses. And as you can see from this graph, the kilometers traveled in the first year, were much lower than what we had originally anticipated. There's 2 reasons for that. First one being service reductions from the pandemic, and there's nothing that we could have done about that. The second one, though, is related to vehicle and charger reliability. And as you can see from this table, in year 2, that largely started to improve and stabilize, and now into 2022, you can see we're really starting to pick up with expanding our electric bus service and kilometers traveled by the fleet. We do have 12 buses, like I mentioned, and we do at minimum have 8 of the 12 in service every day, but typically we're closer to the 10 or 11. Similar to what Ben had mentioned earlier, we have been keeping a very close eye on reliability with mean distance between failures. What you can see here, kind of similar graph to what Ben had previously. A bit of a plot of where our reliability has been falling, And the positive news is over the last year, a number of improvements have been made, both with chargers and with the buses, to increase the level of reliability. What I can say overall is in year one, implementing a new technology, is challenging, and transit agencies should be prepared for that. And you kind of have to stay the course and work at it, and ultimately we'll start to see an uptick in the reliability like we have here. Again, some of this performance modeling is skewed as a result of the pandemic and reduced kilometers traveled. So it's something that we are keeping in mind as we evaluate the technologies, and hopefully 2022 is more reflective of what we had originally anticipated, and we'll be able to get a really good understanding of how these buses are performing in a more normal environment, I guess you could say. Just a few quick points. Like I mentioned, we did travel over almost 200,000 kilometers. What we have found actually slightly different from what TTC had mentioned previously. About 50% of all of the issues that we've been experiencing have been related to battery and charging systems. You can see it takes up half of this pie chart. The other big standout systems anyways are HVAC, electrical, and propulsion. So I think depending on the environment and the fleet that you have, these metrics are going to vary. And I think the important thing is that all transit agencies with electric buses are keeping a very close eye on reliability and understanding what systems are performing the way we need them to, and what areas need work. So we talked a little bit previously about operating costs, and this is another key metric for us, as I mentioned, for developing business cases and moving this initiative forward. So what we did for the first year in service was obviously track all of the associated operating and maintenance costs when it comes to the electric buses. We don't have any hybrid fleet to compare them to, but obviously we have a lot of diesel buses. So we did do our best to compare these electric buses to a diesel fleet of a similar size and age. And what you can find by doing so, for us anyways, is that 30% or so savings. So you can see some cost tied directly to electricity versus diesel, and then also a pretty decent reduction in PM maintenance costs. So when it comes to emission reductions, I mentioned previously about the region's overarching goal of being emission-free by 2051. We, on an annual basis, report through to an energy conservation and demand management plan, which is the region's opportunity to demonstrate progress being made on emission reductions. And we're very pleased with the performance so far of the electric buses, and we'll be continuing to track and report out on the impacts our program's having. I see I'm running over time. Next steps. So we're going to be getting 2 additional buses this year, like I mentioned. We're working through the Pan-Canadian electric bus demonstration and integration trial. Year 2 will be finished in July. We're working on some funding applications, and we're continuing to seek out opportunities to support our electric bus program. And that's it. I know I'm over time. Thanks.
Thanks, Kyle. Really appreciate all that sharing. I want to take a moment to acknowledge just how much effort organizations like York Region and York Region Transit have put into the road to electrification. It cannot be overstated how much other transit systems have benefited from the road that YRT and Brampton Transit in particular started going down way back in 2016. We wouldn't be where we are now without the commitment to to starting down that road, and others have benefited so much. So I'd like to bring the panelists back and jump in to a few questions here. I see that people are taking advantage of the Q&A, and we encourage you to continue to put questions in there. The panelists will use that feature, but perhaps because we just made it across the finish line this week with a project with CUTRIC, it is top of mind for me. Parvathy, Ben, and Kyle, I wanted to ask you a question about data and getting data from assets like the buses and the chargers. Opta and CUTRIC and the TTC have been able to pull together the resources needed to have a dashboard project that's going to ultimately become part of CUTRIC's ACE's Big Data Trust. This is being undertaken as part of our Zero Emission Bus Committee, and we're thrilled to have been able to finally pull that together. So Parvathy, would you like to start talking about the metrics that we're going to be gathering as part of that exercise?
For sure. If I may take a step back just to ensure, our audience hears the importance of data collection, because the message that we have been trying to, educate our stakeholders countrywide is the feasibility assessment and predictive performance modeling is just one part of the pie. It is, equally important for you to collect data and analyze it. And the Opta dashboard and the cloud transit platform, which is paving way to the ACES data trust that CUTRIC is building nationally, is the building block to doing that. And we would be looking at several metrics like the range, the dependability, the fuel economy, and the availability of the fleet. All of those metrics are captured in this dashboard, and it would be available as a platform wherein the data would be fed into and analyzed and reported on. It would be a one-stop shop for zero emission bus performance data that would be serving as an educational tool for other transit agencies to understand from leaders like TTC and York Region and Brampton and nationally to understand the electric bus performance, where the challenges are and what the operational realities are.
Thanks, Parvathy. Maybe Bem and Kyle, do you mind commenting on the data side of these exercises?
Go ahead, Kyle.
Yeah, definitely. It's extremely important and something that we've been focusing on quite a bit. The presentation that I just went through covered off, a few of the metrics that we're tracking, but ultimately this, new fleet of electric buses and charging infrastructure, there is no shortage of data being generated by them. And at the end of the day, it's only as good as whether you're doing something with it or not. And I think there's a lot of opportunity there to use that information to make informed decisions and improve overall reliability and build business cases, like I mentioned previously, to start moving these initiatives forward.
Yeah, I agree with all of that. Of course, the next challenge for us is to take the data that's been generated off of these assets and build a system, and it's an energy management system that's required, and a smart charging system. There's a bunch of different terms being thrown out there to describe a system that ultimately needs to take data from the bus, from the infrastructure, from our service planning, CAD-AVL systems, and integrate them so that we can manage the service, but also so that we can predict the service before we go out and deploy certain technologies for certain routes and that type of thing. So it's a big challenge that's up ahead. That's part of the scope of work that OPG and PowerOn is taking on in our kind of delivery model. And so it's a huge piece of work, actually, but it's absolutely required for a large-scale adoption.
Thank you. I wanted to move on in keeping with the title of this session, the promise versus the realities. One of the other exercises that Opta is working on with various organizations, CUTRIC, CUTA, and our transit system members, is a scheduling, planning, operations and training review. I think the subhead of a lot of what we've been doing is, buying the bus is the easy part. There's so many other interdependencies. But Kyle, can I ask you, aside from those bus pieces that we've kind of focused on here, what are some of the other aspects that ended up being very different than what you anticipated?
Yeah, I think you're spot on, Karen, right? When it comes to implementing a technology, ultimately for us, the most important thing is service reliability. There's all sorts of cool stuff out there that we can look at doing, but if it doesn't result with reliable service for our customer, then it's kind of all for nothing. So, purchasing a bus, whether it's an electric bus or a diesel or a hybrid, is relatively straightforward, but the potential changes that those technologies could have to your service and your scheduling and your customer, for that matter, need to be included in all of your decision making. And that's the goal, Karen, I guess you could say, of some of these programs that Opta is working on, to provide transit agencies with the tools they need to understand the full picture instead of just bits and pieces.
Exactly. Ben?
No, I agree.
Wonderful. I'm going to take a look at the time here. I know we just have a little bit more time and we're still using the Q&A there, but think a little further down the road then, do you foresee hydrogen fuel cell buses, renewable natural gas buses, retrofitted diesel buses being part of the electrification path forward? Kyle, what are your thoughts on some of that?
Yeah, I mean, some of it's going to be down to technology limitations. Both City of Toronto and York Region are very large geographical areas, and we have some, pretty long-standing, complex routes that go into, rural areas and things like that. That it might not be ultimately practical to, reduce our emissions with, one technology or another. So I think, as all of these technologies mature and we start to better understand limitations overall, it could result with us looking at additional technologies above and beyond electric bus, just based on limitations.
Thanks. Ben, we have very little time left. I'm going to let you have the last minute here.
Sure. So for TTC, we still believe that the depot charge bus will serve about 80% of our fleet requirements. We still don't know whether or not the depot charge bus battery density and charge rate will increase high enough to serve that last 20%. And so we're still actively looking at and going to start planning for, in fact, a deployment of opportunity charge buses in the coming few years, even though we don't need to have we have probably 5 to 10 years before we have to go out en route to address that last 20% of routes. But we want to get the experience with the technology, given that it may very well be that we have to have either opportunity charge buses or hydrogen fuel cell buses. You mentioned renewable natural gas. I personally do not see that as an option. I think that the tailpipe emissions are tailpipe emissions of a natural gas bus, whether the source of the fuel was sourced green or not, and it doesn't have all of the local health impacts benefits that a truly zero emissions bus would have. So for me, it's not something that we're considering at this point anyway. And but for hydrogen fuel cells, certainly, and opportunity charge buses, I would say either or both are likely to be in the fleet mix in the future.
Thanks, Bem. I think that gets us to the end there, and it helps us wrap up. Once you've seen one zero emission bus deployment, you've seen one zero emission bus deployment. There's something to learn from all of them, and your willingness to share information is wonderful. Parvathy and CUTRIC, I cannot say enough about how valuable you are to Opta and the Opta membership. The work that you do is exceptional, and thank you for the opportunity to moderate today.